All right, today for the lesson I'm going to continue with what I talked about for the segment addition postulate, but instead what I'm going to be talking about is dealing with angles addition. There is a note page that is on this. I think it's 9 pages in. If you don't count front to back as 9 pages. At the top of the page it says types of angles, acute, right, obtuse, straight, and then it says the angle addition postulate, and then it says the angle addition postulate angle bisector scenario. Okay, you should see a protractor on that page as well. You can follow along with my notes that I gave in there, and that'll make things a lot easier as you're doing problems. The only thing bad is I did try to shrink it onto one page, so it is sometimes hard to read. So you may want to put it on your own sheet paper anyway. All right, vocabulary terms that you're going to use is angle bisector. When I'm talking about an angle bisector, I have an angle, okay, whose measure on both sides, okay, as I look at this, okay, the angle on one side has to have the same measure as the other side. So if I came over here and said that this angle right here was 40 degrees, then I know that if it's an angle bisector, this angle right over here is also 40 degrees. Okay, looking at this shape down here in the second one, right down here, it says, how do you name congruent angles? Well, you can see right here that I put a mark right here in this angle, and I put a mark in that angle right there. So angle BGC is going to be congruent, and the congruent symbol looks like equal sign with a little squiggly mark over it, okay, to angle DGE. Now, the congruent symbol, okay, don't worry about it. It's just another way to say that you have corresponding parts in congruent order. It's another way to write an equal sign. Okay, but these are the two angles that you're going to use that are equal. The angle addition postulate. Okay, in this problem right here, it says RT is in the interior of angle ARC. So if I was to draw a picture of this, okay, I would draw, okay, my angle A, okay, R, and C. And RT is in the interior of it. Okay, so if I was to put a segment or a ray right here, this is a ray because it has a little line or an arrow going in one direction. Okay, I can draw this anywhere in the interior of it. Okay, right there is that spot right there. So if I was to add these angles together, okay, I know, and I'll color code these as much as I can, this angle right here, which we're going to call angle ART. Okay, if I add on, okay, this angle, then I'll put in purple, angle TRC, I will get the length of the entire angle that I highlighted right there in black, angle ARC. Now, how would I go about doing a scenario with this in there? Okay, so if I scroll down to this next one right over here, I can do the angle bisector scenario. Okay, with that same type of scenario here, I can draw a picture. Okay, I will draw a picture ARC here now. On this one right here, instead of me having RT just be anywhere in there, if it bisects it, okay, when I go about drawing this ray right here, okay, in the middle of it, I meant to draw that in green, okay, I know that this angle right here has to have the same measurement as that angle right there. Okay, so when I look at this as being an angle bisector, what I would say here is that angle AR, and this, sorry, I forgot to put T over here. There's T, angle ART. Okay, so this angle that I highlighted in green is going to be the same size as angle TRC. Okay, how do I go about dealing with the angle addition postulate and the angle bisector postulate? Well, if you look at the picture that I gave you right over here, and I put some information in the picture. Okay, it says angle RSV is 89 degrees. So in the picture, the more information you put in the picture, the better the easier this stuff is. So I'll put 89 degrees in the picture. Okay, now I covered up this other part. Let me slide it up there. Okay, so then it says, okay, here, now highlight this in red, that angle RST is 35 degrees. Okay, so if RST is 135 degrees, so the whole thing is 135 degrees. If I was to add, okay, this little green angle, okay, plus this blue angle, so angle RSV, if I add on angle VST, okay, I will get the entire angle RST. Okay, so as I'm looking at this, I'm adding, and this is the angle addition postulate. I'm adding two angles to get the size of one big angle. Okay, in my amounts right over here, it looks like you can tell right here that that amount, RSV, is 89 degrees already. Okay, I do not know, okay, what this amount is, okay, right here. That is an unknown amount right there. But I do know that it adds up to 135 degrees total. So if I wanted to find out what was left for that green angle VST, okay, simply I would just have to subtract, okay, 89 from the entire amount of 135. So my angle that I'm left with, okay, is going to be 46 degrees. And you can double check my math there. Okay, but this angle right here is 46 because I essentially did 135 minus 89, okay, and came up with, you can do the math, borrow right here, come up with 6, okay, 46 degrees. Okay, now looking at example number 2, okay, it says RSV. So RSV is 36 degrees. Okay, well, if angle RST is 180, if it's a straight angle, we know this amount right here is 180 degrees. So if we're going to try to find out what's left over right here, we got to find out that missing amount. We can take 180 degrees and subtract that 36. That should be able to find out that missing amount that we have right there in blue. Okay, doing a little bit of math here. Okay, borrowing and subtracting. I'm going to come up with 144 degrees. Okay, so that's what I get to find angle VST. That's the angle I put there in blue. Again, this is called the angle addition postulate. Okay, now if I look over here and I write down some things here, it says BD bisects angle ABC. So here we go. We have ABC right here. Okay, when I drew in this ray right here, it says it bisects it. When it bisects it, that means it's going to be the same amount on both sides. Okay, so now it said after that, that I'm going to let this angle right here that I'm highlighting in purple have a measurement of 6x plus 3. I'm going to let, okay, my other angle, DBC, that's this angle right here that I'm highlighting in green, DBC, be 8x minus 7. Now, since it said it was a bisector right here and both of them are equal, we do know that this purple angle right here, angle ABD, okay, it has to be the same size as the one I highlighted in green right there, angle DBC. That this is only true because, again, it bisected it, creating two equal angles. So, with that said, okay, I'm going to come up here and I'm going to say, okay, that angle right there was 6x plus 3. I substituted in to this formula right there what angle ABD is. It's the same thing that I had right up here. Okay, I'm going to do the same thing here with DBC. I'm going to put 8x minus 7 here for DBC. Okay, so from there, okay, I'm going to be able to go about solving. If I subtract 6x to get the x's on the same side, I will have those cancel out. Okay, what I'm going to have left here is 3 equals 2x minus 7. Okay, from there, I'm going to add 7 to both sides. That's going to leave me with 2x equals, well, that cancels the 7's here, but it leaves us with 10 here. Okay, I finally can come up here and divide by 2, and I get x equals 5. Okay, now all of this is the work you have to show to do this. I will give you 1 point for knowing that you set those formulas equal to each other. I will give you 1 point for putting the formulas equal to each other. Okay, and if you come up here and solve, okay, and show your work, okay, I will give you 2 points for it. And the final step is I wanted to come up and find out angle ABD's measurement. Well, angle ABD, as we found out right over here, okay, has an algebra formula of amount of 6x plus 3. So if I want to find out angle ABD, and we know it's 6x plus 3, all I need to do is come up here, and where this x is 5, okay, I'm going to put a 5 in place of that x. So if I multiply now my 6 times my 5 and add on 3, I'll come up with 33 degrees. And that is my measurement that I'll have for angle ABD. All right, so that's example 3. Okay, I'm going to do a couple more here. Okay, on this next one right here, example 4, I'm going to find angle ABC and CBD. Okay, so on this one right here, you're going to notice right away that this right over here has to be 90 degrees because that box right there is 90 degrees. And since angle ABD has to be make a linear pair, okay, with the angle ABE, we know that, and I'll highlight this part in blue, this little box right here is also 90 degrees. Okay, because we know angle ABD is 90 degrees, okay, we then can come up here and say, okay, angle ABC, that's the part I put in purple, okay, plus, okay, I'll put this part in blue, angle CBD, they have to add up to that total 90 degrees. Okay, once you have that all set down, okay, you can come up here and you can substitute in. Okay, so you got 1 point right here for putting that geometry set up. Okay, then I can come in here and I see, oh yeah, the purple one has 2x. Okay, this blue one right up here, okay, is 3x minus 10, and that all equals 90 degrees. Okay, put the algebra in the problem. That's the next step. Okay, now we have to come up here and we have to solve. Combine the x's together. Since they're on the same side, they just combine together. Rewrite. Okay, get rid of your subtracting 10 by adding 10 to both sides. Okay, finally cancel out the 10's. We have 5x equals 100, divide by 5. Okay, and we're going to come up with x equals 20. Okay, solving of all that, showing your work. Okay, that's going to be worth 2 more points. Okay, we have to come up here and we have to see what was the exact thing that we were trying to find out. Well, we wanted to try to find out ABC and CBD's measurement. Well, angle ABC, okay, was equal to this 2x. So if I plug in and I found out x to be 20, 2 times 20, okay, I will come up with 40 degrees. Okay, so that's the length of that purple little part, okay, right there. If I want to come up with the blue part that I have over here, angle CBD, I know CBD is 3x minus 10. Plug in the 20 again, in for the x. Do the math, 60 minus 10, and I come up with 50 degrees. Okay, you get 1 point for finding the length of ABC, 1 point for finding the length of that. We have a total right here of a 1, 2, 3, 4, 5, 6. Okay, we have a 6-point problem. All right, and my last example. Okay, my last example up here is now going back and talking about an angle bisector. Okay, we can see right away that JK, it said, was an angle bisector. Okay, when we know that there's an angle bisector, we know that this green angle right here, LJK, has to have the same measurement as this blue angle right here, angle KJM. So what we're going to do is we're going to come up here and that's what we're going to state. We state LJK, the green angle, has to be equal to, because it was cut in half, because that's what bisects means, angle KJM. Okay, so there's our first part right here that we call our algebra, our geometry setup. We are then going to come back up here and we're going to plug in the algebra. Okay, 10x plus 3, that was the length of the green angle right there. Okay, we're going to plug in negative x plus 21. That's the length for the blue angle. Okay, we got our algebra in there, and now it's a process of solving. Okay, my recommendation is always taking and moving the x's to the same side. Okay, always bring the smaller x to the larger x to avoid having to deal with negative variables. Those x's right there are going to cancel. Okay, and what we're left with here is 9x plus 21 on the right side and only 3 on the left side. After subtracting 21, okay, from both sides, I'm going to have 9x on the right side, okay, and negative 18 on the left. Okay, simplify by dividing by 9. Okay, and I come up with my answer here for x to be negative 2. Okay, again, show all that work. Okay, that's going to give you 2 points. And the last little part was, what were they asking us to find? It said determine the length of LJM. Well, LJM is this green angle right up here. That is LJM. So if we want to find angle LJM's length, we're going to have to plug that into this negative 10x plus 3. So in order to do that, we're going to take negative 10, okay, plug in the negative 2 into where, okay, our x is right here. So we got negative 2. Okay, do our arithmetic here. We're going to come up with negative 10 times negative 2 is positive 20. Add on 3, and we get a length of 23 degrees. I hope that helps you out here of how you're going to deal with angles, just like we dealt with segments. Okay, I'll try to answer some more questions when we come back here in 2 days. I'll talk to you about how to read a protractor, and then we'll do a couple examples as warm-ups in class.